Hey guys, my name is Yash Ahuja and I will be walking you through Physics 2212 Lab 1 titled Charge Tapes. So the goal of this experiment is to create a computational model of two charge tapes to understand how charges work around us on everyday objects. We're going to use our knowledge to quantify the amount of charge and the excess charge. So the concepts used in this lab are Coulomb's law, Newton's second and third laws, and to understand that we need to understand the concept of vectors. The purpose is to use clear tape to model and calculate the exchange of charges and the transfer of excess charge. Looking ahead, the results were that the charge on the tape was negative 1.2 times 10 to the power minus 8 coulombs, and negative implies an excess of electrons. So, like I said, the concepts used are Newton's second law, third law, and Coulomb's law. Newton's second law states that F is equal to ma, and Newton's third law states that every action has an equal and opposite reaction. And Coulomb's law relates electric fields and forces with point charges at a distance. Now let's look at the procedure of this lab. We're going to create a U-tape by quickly pulling the tape strip off the base tape. This can be seen in figure 1. We're going to ensure that the tape is negatively charged by rubbing a plastic pen and observing repulsion with the tape. It is necessary to observe this repulsion as charged objects can still attract neutral objects because of polarization. Now we're going to repeat steps 1 and 2 until we have two total charge tapes. Now we're going to lift one tape under the other until the top tape floats. And now we're going to record the distance between the two tapes. Now let's look at the model and the assumptions that we made. So the physical model includes two tapes that repel each other with equal magnitude because they are both negatively charged. They have the same magnitude of charge. The tape on top floats with no net force as the electric force due to A is counteracted by gravitational force. Now let's look at the assumptions we made. Firstly, the tapes are assumed to be point charges and that the tapes have the same charge. We're going to use the length to approximate the mass and the number of atoms. We're also going to assume that the atoms are in a perfect lattice and that air resistance is negligible. Now let's look at the measurements and data. So the values we recorded were the length of the tape, the width of the tape, and the vertical distance. The values can be seen on the screen. Also, we assume that the length of the tape is the same for both the tape strips. The calculated values include the tape weight, which was calculated to be 2.3 times 10 to the power negative 3 newtons, the surface area, which was 0.0052 meters squared, and the number of atoms, which was 5.2 times 10 to the power 17 atoms. Now, this is the calculations. Now we can see that the electric force on B due to A in vector form can be expressed as 0, 2.3 times 10 to the power minus 3 Newton. Now we're going to use Coulomb's law to approximate the charge with the given distance. We've used Coulomb's law as you can see over here, which is 1 over 4 pi epsilon naught times q1 times q2 divided by distance squared, and the charge of the tape was found to be negative 1.2 times 10 to the power minus 8 coulombs. We've also calculated the number of excess electrons by using the charge on one electron. We found this number to be 7.5 times 10 to the power 10 electrons. Now let's look at the ratio of excess electrons to atoms. This was found to be 1.1 is to 6.9 times 10 to the 6. Now we use the GlowScript IDE and Python to make calculations, output results, and render a virtual 3D simulation. I've linked my GlowScript code in the description box. So now in GlowScript, these are the values I defined before. This is good coding practice because if we change the value of these variables, then the calculations adapt automatically. These are the computations we made, and you can see that we have printed the necessary values. I've included two screenshots. And yeah, these were the results: the surface area, the number of atoms, the excess electrons, the charge on the tape strip, and the ratio of excess electrons to atoms. Now, this is the main code for the 3D simulation, and as you can see the photo of it on the right. Because we had to do this multiple times, it was easier to define a function. So you can see that we have designed the function over here to calculate it, and then at the end we are just drawing the forces in. Now looking at the reflection questions, if the electrons and protons had inverse charges, it would not change anything The tape charge will be positive, however, since they are both going to be the same charge cell, the same sign, both positive, they're still going to repel. It's important to handle the charge tapes as little as possible because the interacting with other objects may cause tapes to lose electrons as the electrons will transfer to the more neutral object. Thank you.